Welcome to the deep dive. We like to deep dive into all sorts of cool stuff.
Absolutely.
And today is no different. We are talking about neuro-symbolic AI. So this is really like the cutting edge of AI right now.
Yeah, it's kind of like the Wild West out there.
It is. It's where we're trying to blend, that symbolic AI,
Right.
all that logic,
Yep.
with the learning power of neural networks. And we're going to be using a really awesome, fresh off the press systematic review called Neuro-Symbolic AI in 2024.
Very cool. Like Spock meeting Data,
Yes.
if you're a Star Trek fan.
Perfect analogy. I love it. So you can kind of think of this. Imagine if AI could not only just process data,
Yeah.
but it could understand it and reason about it like we do.
Right, right.
That's the promise of Neuro-Symbolic AI.
Exactly.
And this paper gives us like a snapshot of where we are in the field.
That's right.
Right now. These authors looked at a mountain of research, like over 1,400 papers.
Wow.
And they narrowed it down to 158 projects
Yeah.
that have publicly available code.
That's great.
Which is huge. They really emphasize the reproducibility.
Absolutely.
Which, in this field,
Yeah.
that moves so fast,
Especially.
is just so important.
It really is, yeah. Makes a big difference.
And it's interesting because this whole idea of neurosymbolic AI, it's kind of part of a larger pattern that we've seen in AI research.
Absolutely.
Right.
It's
You were talking about the AI roller coaster.
yes. The AI roller coaster.
Exactly, these cycles of hype and disillusionment.
We've seen these periods of really intense excitement,
Right.
which we call the AI summers.
Yeah.
Followed by, disappointment and funding cuts. And those are the dreaded AI winters.
The AI winters.
Yeah. And right now we are currently in what we'd consider the third AI summer. And Neuro-Symbolic AI is one of the hottest tickets around.
So why do we think this cycle happens?
Well, I think it's partly human nature.
Yeah.
To get super excited about new technology and then, crash back down to reality when it doesn't quite meet those early expectations.
It's like it never lives up to the hype right away.
It takes time. And there's often a gap between those early promises and what AI can actually deliver in, a short amount of time.
Okay.
But I think this time does feel a little different,
Why?
because we are starting to see some real breakthroughs in combining different AI approaches. And that's where I think Neuro-Symbolic AI really comes in.
So I think before we even get into why that combination is so important, maybe we should define what those different approaches are.
Okay.
We hear a lot about symbolic AI, sub-symbolic AI, but what do they mean?
Right.
Yeah.
So when we think about symbolic AI, think about like the original gangster AI, the OG, the rule-based system.
Okay.
And it uses symbols and logic to represent knowledge.
Right.
It's kind of like, those early AI systems that tried to understand language by following a set of pre-programmed rules.
Okay. So that makes sense. So when we talk about sub-symbolic AI, this is where it gets a little bit more, sub-symbolic.
Yeah, a little more messy.
Yeah. Instead of explicit rules, it's about learning patterns from massive data sets.
That's right. So this is where machine learning and deep learning really come into play.
Okay.
Think of, the GPT models writing poems, DALL-E creating those crazy images. They're not really following a specific set of rules. They're learning patterns from all the data that's being fed into them.
So while that traditional symbolic AI relies on those hard-coded rules, the sub-symbolic AI is more about letting the data guide the process.
Right.
Okay. So where does neuro-symbolic AI fit into all of this?
Neuro-Symbolic AI aims to kind of bring those two together. Harness the strengths of both approaches.
Got it.
This paper defines it as a composite AI framework that seeks to merge the domains of symbolic AI and neural networks to create a superior hybrid AI model possessing reasoning capabilities.
Okay, that sounds super complex.
It is.
How do you even begin to bridge that gap between a logic-based system and these data-driven neural networks? How do they even talk to each other?
Well, that's where those 5 foundational research areas that were identified in the paper, that's where those come in.
Okay.
So we have knowledge representation.
Okay.
And that's all about figuring out how to represent knowledge in a way that both systems can understand.
Right.
And then we have learning and inference, where we're really trying to combine the learning power of those neural networks with the reasoning abilities of that symbolic AI.
Okay.
And then explainability and trustworthiness. We've got to make sure that these systems are transparent, that they're reliable.
Of course. Yeah.
And then we have logic and reasoning. So essentially trying to get neural networks to think logically,
Okay.
which is a challenge in itself.
Yeah.
And then perhaps the most interesting area is metacognition.
Ooh, metacognition. AI that can think about its own thinking.
Right.
Exactly. Yeah.
Now we're getting into some deep philosophical territory here. Absolutely, yeah.
I love it.
That's precisely why it's so fascinating.
Okay.
It's about the system's ability to self-monitor,
Right.
evaluate, and adjust its own reasoning process. It's still relatively unexplored, but it's considered really crucial for achieving true AI autonomy and adaptability.
So these 5 areas are like the pillars.
Yeah, you can
Like
think of it that way,
Okay.
for sure.
So where's the action happening right now? What are some of the trends that the paper uncovered?
Well, remember we talked about that huge explosion in research after 2020?
Mm.
Well, most of the recent work is focused on learning and inference, knowledge representation,
Mhm.
and logic and reasoning.
So the bulk of the research is really focused on those foundational challenges of combining those two.
Exactly.
It makes sense that researchers are still grappling with how to get those two brains to work together.
Yeah, exactly. And, what's interesting is that despite its importance, there's a surprising lack of research in certain areas.
Yeah, like explainability and trustworthiness. We touched on those earlier. But I think you mentioned metacognition is even more neglected.
Yes, very much so. Only a tiny fraction of the papers that were analyzed in this review actually focused on metacognition.
Really?
Yeah. It seems like we're racing ahead with building these powerful AI systems
Right.
without really fully understanding how they think
Mm-hmm.
or ensuring that, they can actually reflect on their own reasoning processes.
That kind of sounds like we're building a rocket without a guidance system.
It's a good analogy, yeah.
So this gap in explainability, trustworthiness, and metacognition,
Yeah.
is it a problem? Is it an opportunity? Or is it both?
I think it's definitely both.
Okay.
These gaps represent some major challenges, but they also point towards the areas where the next generation of AI breakthroughs might occur.
I see.
Imagine what AI could achieve if it could not only reason, but also think about its own thinking.
Yeah.
The possibilities are really pretty mind-boggling.
That's an exciting thought.
It is.
But I think we've talked enough theory. I want to get into some specifics now.
Absolutely.
Are you ready to dive into some actual projects that showcase what Neuro-Symbolic AI can actually do?
Let's do it.
Okay, awesome. I'm all ears.
All right.
Let's go.
Lead the way.
All right. Okay, so let's talk about some of these projects that are really like pushing the boundaries of Neuro-Symbolic AI.
Okay, I'm ready.
Okay, you ready to have your mind blown?
Yeah, let's do it.
Okay, so there's a system called alpha geometry,
Okay.
and it tackles high school level Euclidean plane geometry problems.
Wow.
And not just the simple ones, like we're talking Olympiad level challenges.
So like hardcore geometry.
Legit geometrical problems.
Okay, that's impressive.
Yeah.
But how does it actually work?
All right, so this is where it gets really interesting.
Okay.
It combines a neural language model,
Okay.
which is trained on this massive data set of theorems and proofs,
Right.
with a symbolic deduction engine.
So is the neural network like the intuitive part that like
Yeah.
spots the patterns and potential solutions?
Yes, exactly. Out of like a million possibilities.
Exactly. It's like sifting through millions of potential paths
Wow.
and then guiding the symbolic engine toward the most promising ones.
Okay.
And then that symbolic engine kicks in. It's like the logician, rigorously proving each step of the solution.
So what's so fascinating to me is that alpha geometry isn't just like solving problems. It's actually like generating those human readable proofs.
Exactly.
Like an actual mathematician would.
Yep. And that's a level of explainability that we just don't see very often in, traditional AI.
Exactly. And that's what's so important about this. When
Yeah.
we're talking about building trust in AI systems, right?
Right.
Like if we can understand how it arrives at its conclusions, then we're more likely to like accept them.
Absolutely.
I actually like use
Yeah.
them in critical situations.
That's right. Explainability is key.
Okay, cool.
And speaking of understanding how AI systems reason, there's another project that I thought was really cool.
Okay, what is it?
It's called NeuroQL. It's this domain-specific language
Okay.
for intersubjective reasoning.
Intersubjective reasoning.
Yeah,
That sounds intense.
it is pretty intense.
What does that even mean, like in the context of AI?
So it's about understanding how different agents, like whether they're human or AI, perceive and reason about the world,
Okay.
how they form beliefs,
Yeah.
and make decisions based on their individual perspectives and knowledge.
So it's not just about AI like understanding logic. It's
Right.
also about understanding how other minds work.
Exactly. Yeah. It's about understanding those different perspectives
Okay.
and how those perspectives influence reasoning.
That's a pretty high bar
It is a high bar, yeah.
for AI to clear.
And that's what makes NeuroQL so remarkable.
Okay.
It tackles this challenge by capturing these complex, long-range relationships
Okay.
between entities, enabling it to model how different agents interact and reason about the world.
So it sounds like NeuroQL is really pushing the boundaries of what we thought was possible with AI, especially when it comes to like modeling those social interactions, those complex decision-making processes.
Yeah, it really is.
Wow.
And what's even more impressive is that NeuroQL does all this with remarkable efficiency.
Oh, wow.
It's a great example of how Neuro-Symbolic AI can actually lead to more efficient learning
Right,
and
yeah.
reduced computational costs.
Yeah. Do more with less is always a good thing.
Always a good thing, especially in AI.
Especially with all the resources AI needs.
Exactly, where computational resources can be a major bottleneck.
Yeah. Okay.
But let's maybe shift gears a bit
Okay.
and go back to that topic of metacognition.
Yeah, it keeps coming up.
It keeps coming up for a reason.
Yeah, for good reason.
It really is like the holy grail of AI.
Okay.
It holds the key to creating these AI systems that are truly autonomous, adaptable, and reliable.
Right.
And while it's still very early days, there are some researchers out there that are kind of bravely venturing into this uncharted territory.
So what are they doing?
Yeah, what are they up to?
What are these pioneers of AI metacognition working on?
Well, one approach involves using reinforcement learning to approximate those metacognitive capabilities.
Reinforcement learning. So that's where the AI learns by trial and error.
Yes.
Gets rewarded for good decisions, punished for the bad ones.
That's the gist of it.
Okay.
But what's really new here is that researchers are adding this like metacognitive layer
Okay.
on top of that traditional reinforcement learning framework.
Gotcha.
So they're trying to teach these AI agents not only to learn from experience,
Right.
but to reflect on their own learning process.
So it's not just about like maximizing those rewards, but also understanding like why they got those rewards in the first place?
Exactly. Yeah, that deeper level of understanding is crucial
Right.
for AI to operate really effectively in these complex and unpredictable environments.
Totally.
It's the difference between blindly following a set of rules and actually being able to adapt and learn on the fly.
So like giving AI the ability to think about its own thinking could lead to some major leaps forward. Absolutely.
In terms of like adaptability,
Yeah.
resilience in different situations.
For sure. And it's not just about reinforcement learning either.
Oh,
Another really exciting avenue of research involves integrating what are called cognitive architectures
okay.
with powerful language models.
Cognitive architecture. So those sound kind of like blueprints
Yeah, you could think of them that way.
for like the human mind.
In a way, they are.
Okay.
They're attempts to model all these different components of human cognition, like memory, attention perception, and decision-making.
And by combining these architectures with like the vast knowledge and linguistic capabilities
Yeah.
of like the language models like GPT,
Right.
are we saying that we could create AI that can not only like process language,
Yeah.
but also reason, plan, and learn
Yes.
in a more human-like way?
Exactly.
So we're not just talking about AI that can like parrot back information
Right.
or follow those pre-programmed instructions.
Yeah. We're talking about AI that can actually think for itself, make its own decisions, and even set its own goals.
That's the ultimate aspiration.
Wow.
And these cognitive architectures are providing a framework for that.
Okay.
They're helping us to break down that really complex process of human thinking into these manageable modules that we can then implement in AI systems.
So this is all incredibly exciting. I have to ask like the million-dollar question.
Yeah.
When can we expect to see this
Right.
in our everyday lives?
Right. When is this going to be real?
Yeah. Is this still science fiction, or is this like science that's rapidly becoming reality?
That is the question everyone wants answered.
Yeah.
And honestly, it's hard to say for sure.
Okay.
But what we can say with confidence is that the pace of research is accelerating.
Okay.
And we're seeing real progress in bridging that gap between theory and practice.
So this isn't just a pipe dream.
No, it's not just a pipe dream.
There's like a real sense that neuro-symbolic AI could be like the next big wave
It could be.
in artificial intelligence.
It really could.
One that could fundamentally change like how we interact with technology
Right.
and the world around us.
Absolutely.
And that brings us back to our deep dive
Yes.
into this systematic review.
Right.
We've explored the hottest trends, the breakthroughs in neurosymbolic AI,
Ah,
but we've also uncovered some pretty significant gaps
yes, we are.
that need to be addressed.
Absolutely.
Those gaps in explainability,
Yep.
trustworthiness, and metacognition
Yeah.
are like crucial challenges that we need to really tackle head on.
We do if we want to build AI that's not only intelligent,
Right.
but also safe, reliable, and aligned with human values.
And this is where I think it gets really interesting.
Okay.
This paper that we've been discussing focuses on like the current state
Yeah.
of like neurosymbolic AI research,
Yeah.
but it doesn't really delve too deep into the potential future implications of this technology.
We've talked about AI that can reason,
Yeah.
think about its own thinking,
Yeah.
and even understand how other minds work.
Exactly.
But what happens when AI starts to surpass human capabilities
Yeah.
in these areas?
Whoa.
What happens when AI becomes more intelligent, more creative, and even more self-aware than we are?
That's a big question.
It is a big question, and I think it's one we need to start asking now before this technology gets too far ahead of us.
I agree.
We need to really think deeply about the potential consequences of creating AI that's not only powerful,
Right.
but also potentially autonomous and self-directed.
It's kind of like opening Pandora's box.
It really is.
Mhm.
We're unleashing a force that has the potential to reshape our world in some really profound ways,
Yeah.
and we need to be prepared for both the challenges and the opportunities that come with that.
Absolutely. And that's why these deep dives are so important.
I agree.
They're not just about exploring, these fascinating new technologies,
Right.
but also sparking these critical conversations and engaging with those ethical and societal implications.
Exactly.
We need to ensure that like the development and deployment of AI,
Is guided by human values,
it has to be.
and it has to serve the best interests of humanity.
Absolutely. It's a responsibility that we all share.
So for our listeners out there, what are your thoughts on all of this?
Yeah, we want to hear from you.
What stands out to you as like the most exciting or even like the most concerning
Yeah.
aspect of neurosymbolic AI?
What questions are swirling around in your mind
Yeah.
as we kind of delve deeper into this uncharted territory?
We've covered so much in this deep dive into neurosymbolic AI,
We have.
from like the technical side, like the nuts and bolts of it all,
Yeah.
of how to combine, those neural networks with those symbolic systems,
Hmm.
to the broader like philosophical questions
Yeah.
about the future of AI and its impact on like humanity as a whole.
Yeah. Absolutely. And I think it really highlights just how important it is to have these conversations now.
Right.
While the field is still relatively young,
Right.
we have a chance to shape its trajectory. Totally. We need to move beyond like the height
Right.
and the fear
Uh-huh.
and engage in a thoughtful and nuanced discussion about the potential benefits and the risks of this technology.
Absolutely. I think we need to be asking ourselves some tough questions.
Yeah. What kind of future do we want to create with AI?
Exactly.
What values should guide its development?
Yeah.
How can we ensure that AI remains beneficial to humanity and doesn't become something we can no longer control?
Right. What are those guardrails?
Yeah, and maybe like the most important question, how can we equip ourselves
Yeah.
with the knowledge and the skills
Right.
to navigate this rapidly changing world?
That's where resources like this systematic review paper
Yeah,
become so valuable.
totally.
They provide a snapshot of where things are right now,
Right.
highlighting those key trends, the breakthroughs and the
The
challenges
challenges, of course.
that we face.
And they also serve as like a springboard for further exploration, right?
Absolutely. They inspire us to delve deeper, to read those full papers,
To read more.
to actually look at the code bases of these cutting-edge projects,
That's so cool.
and to keep asking those critical questions.
The future of AI is not something that's going to be decided by a select few,
Right.
up in some ivory tower.
It's a collective endeavor.
Yeah,
It requires the participation of everyone,
everyone.
from researchers, engineers, to policymakers and citizens.
So to our listeners out there, we really encourage you to join this conversation.
Yeah, don't be afraid to dive into the technical details,
Yeah.
to grapple with the ethical challenges,
Yeah.
to really imagine those possibilities.
Because the future of AI is ultimately in our hands.
It is.
And by engaging in these discussions and
Yeah.
making informed decisions,
Absolutely.
we can shape a future
Right.
where AI serves humanity and empowers us to create a better world.
Well said.
Thank you so much for joining us on this deep dive
It's been a pleasure.
into the world of neurosymbolic AI.
Likewise.
And until next time, keep exploring, keep learning, and keep questioning.
I'll understand it better myself.